think I'll be very, very quick. So just about 5 to 7 minutes. And yeah, if this doesn't work, then we'll have lunch earlier. So basically, my name is Prakasha. So I'm coordinating Colossus project along with some other project like EU Impact Monitor, which Angelos will mention tomorrow, and some other impact assessment project. So in DLR, I think in Colossus, it's the same like all, it's with other sister projects. So led by DLR, and we have industry, academia, and universities as partner. So the main idea of this project is like we need to have a digital framework to play around for the two use case, which is very important in Europe. One is intermodal mobility, because as we see, to travel from anywhere to anywhere, it's quite hard. So from north to east, north to south, or east to west. So also how this new modes of vehicle can enable traveling. Example, if somebody wants to ski in Alps, so usually it takes 2 days to go to the ski Spitze. But if you have new modes, can we enable better travel? And also bring all that, you all know that a lot of North Europeans come here on one weekend and everything is crowded and people don't like it. We've seen it everywhere and all that. But if new modes can enable travel in different times, then there could be many weekends, it could create economy, jobs, everything. So that's intermodal mobility. And then wildfire, we all know, I think last week, so my colleague Nick, he created a lot of simulation last night and everything. He assumed that I understand all the regions, so I might be wrong in some region, but he almost took the realistic data. You will see some simulation. And here we design aircraft for fighting wildfire, both how we use AAM, which will be built in hundreds and thousands, which can also be used for fighting wildfire. And also I found by talking to everybody, some fires were created to create land for real estate. But anyway, we are talking about the large fires. So basically, if you want to have a framework, so I think we all know from push and pull from Steve Jobs. So basically, if you have an aircraft like AM, you need to push it to the system like A380 or anything and see how it makes sense. This is what I said about mobility. You have a new AM, and how can we enhance European movements and sustainability and all those things. So this is push. So you push this AM vehicle and see how we can use this to make Europe a better place for traveling and making people travel from one place to another. Pull is, we have this wildfire, and how do you use same AM and seaplanes to fight this wildfire? So you pull it. So basically, like you have a situation and you need a product to work on this, and then we have this simulation, business model, and everything covered in our system of system approach. And to do this, first we need stakeholders, scenarios. So first we need to understand what problem we are solving and who are the stakeholders. Else, the day we solve problem, there is new stakeholder and new problems and new KPIs. And then this is a solution space where we design the vehicle. Also we architect. So architect means once you have an aircraft, it doesn't give you everything. So you need to play it in a nice way. So there are 3 C's: compose, configuration, and control. It's like you have different musical instruments, and just because you have musical instrument doesn't mean that you have nice symphony. You need to play all these things together in a nice way. So this is what we want to play along all these things. And where do you practice this symphony is agent-based simulation, like we saw in the previous presentation. For both intermodal and wildfire, we have a small humble simulation, which can also use for reinforced learning for both push and pull of the products. So and then you evaluate different business model and whether this product is correctly designed for the application and whatnot. And we have a simple dashboard to evaluate. And then basically, as we saw from the previous speaker, you can use reinforcement learning and play some games. I think in this project, you have vehicle design, you do operation, ConOps and everything, and then you bring together in a sandbox or an agent-based simulation, and then you show it how best you can architect everything together. And then we have several tools which we can share with the partners, which is listed, and we can also talk tomorrow. Nabi will share more on vehicles we can share, simulation we can share, all those things we can show. So talking about wildfire, I think this is what last week happened. We were seeing in the news about many aspects which is burning, and also every year this is happening. Actually, we started this work even before the project got approved because it was very emotional. We all can complain, but animals and plants can't cry or complain. So we thought it was very emotional. A lot of students did this work before the European project. And then, so can we have mimic the situation? I'll go very quickly. So this is 3-minute video, but I'll talk through it. So basically, there is fire at Drosopigi. I'm sorry if I'm pronouncing. And then you can simulate the realistic data. That means you take the realistic temperature, wind, everything from whatever available online, and then we try to simulate. We take the vegetation index. Also, we use the simple model because we need to run for reinforcement learning, everything, not a super high-P simulation because it will be very heavy. And then as you can see, so you have multiple aircraft, and then also at T plus 4 hours, there was second fire here. So here you can see there is a new plane. This is a newly designed vehicle in our project. So you take the existing vehicle and then add a new plane, and then you try to fight fire. There are some publications and everything. What if you don't have the new one? What if you have a same fleet? And all those things were part of the publication.